Example 4, find the inverse function, which is f inverse of each function f. Find the range of f in the domain and range of f inverse. Okay, so part A, f of x equals 3 cosine of x plus 1. This right here is restriction for x, which means it's the domain of f. That's why in the instruction it says only find the range of f, so because the domain's already provided for us. So to find the inverse, we will switch x and y for x. So this is f of x, which is the same as y. We will go then make it x equals 3 cosine of y plus 1. Then solve for y. Move 1 to both sides. So x minus 1 equals 3 cosine of y. Get rid of the 1/3 by multiplying the whole thing by 1/3, or you can even divide everything by 3. It doesn't really matter to me. So this is 1/3 times x minus 1 equals cosine of y. You can easily distribute that. Now if you divide everything by 3, it would look like this. Okay, now we have to solve for y, meaning that we have to go in and compose this by cosine inverse. What you do to one side, you do it to the other side. So now cosine and cosine inverse will cancel each other out. So you can end up with a y equals cosine inverse of x minus 1 divided by 3. Or you can easily have had cosine inverse of 1/3 times x minus 1, or you could have distribute the 1/3 out. Not important to me. At this level of mathematics, you guys are pretty good with algebra. Now we have to answer a couple questions. It says here, find the range of f. Well, the range of all cosine, parent cosine, okay? So if I just give you this, y equals cosine of x, the range is from -1 to 1. Now, but if I give you y equals 3 cosine of x, that is now the amplitude of 3. That means the amplitude, if you guys remember, what is the height from the center? So now you go up 3 and then down 3. So the range is really from -3 to 3. But your f function is really 3 times cosine of x plus 1. The additional 1 on the end right there is a vertical shift up 1 unit. So if you shift up 1 unit, what are you really doing? You're adding 1 to the y's. If you add 1 to the y's, then your range is now really -2 all the way to 4. So the range of f is -2 to 4. Now, the domain and range of f inverse is super easy, okay? Domain of f inverse, range of f inverse. All you got to do is you go find the domain and range of the regular and switch them. So the domain of f inverse is the range of regular, which is from -2 to 4. And the range of f inverse is the domain of the regular, which was already given to us, 0 to pi. And highlight or box all of those up. There you go. Part B. Given to us, f of x equals 2 tangent of x take away 3. And they gave us a restriction from -pi/2 all the way to pi/2, which is the domain of f. So now, let's switch x for y and y for x, and then solve for y. First things first, add 3 to both sides. So now you have x plus 3 equals 2 times tangent of y. Divide both sides by 2. So now you're going to have x plus 3 all over 2 equals tangent of y. Compose both sides with tangent inverse. Tangent inverse. So now you have y equals, which is really f inverse of x equals tangent inverse quantity x plus 3 all over 2. That is the inverse function. Box that up. Now we have to find the domain of tangent, okay, because the range of tangent, because the domain's already given. This is the domain. Remember, the graph of tangent goes up and down forever, so the range of f is going to be all real numbers. You can write from negative infinity to infinity. That leads me to the domain of f inverse, which is going to be easy since we have already found or given the domain of range of regular. So the domain of f inverse is the range of regular, which is all reals, the range of f inverse, which is the domain of the regular, which was provided for us, negative pi over 2 all the way to pi over 2, non-inclusive. Box that up. Now, you're on example C. They are giving you f of x equals 3 sine of 2x and giving you the domain from negative pi over 4 all the way to pi over 4 inclusive. So switch x for y and y for x and solve. So first, divide both sides by 3. So x divided by 3 equals sine of 2y. And no, you are not going to divide by 2. You have to compose sine inverse first. So now this is going to look like sine inverse of 1/3 x, or x divided by 3, equals 2y. Now we are going to get rid of the 2 by multiplying by 1/2 here, and I'm going to put that 1/2 in the front. So finally, y equals, which is f inverse of x, equals 1/2 times sine inverse of 1/3 x, or x divided by 3. I'm just going to write 1/3 x this time. And no, it does not matter if you write x divided by 3. That's the inverse function. So it wants us to find the range of f. Okay. Now, if I give you y equals sine of x, the range is going to be from negative 1 to 1. If I give you y equals 3 times sine of x, that's an amplitude of 3, so it's really negative 3 to 3, or you can even think of it as a vertical stretch factor of 3. So you're going to take your original range and you multiply by 3, so that's why it's negative 3 to 3. Now, what if I give you y equals the sine of 2x? If the 2 is inside, does it really change your y value? It does not, right? Because this is really a horizontal compression factor of a half. That's really changing the x's by a half. That's why your domain restriction is now half its original restriction. The sine inverse usually has a restriction from negative pi over 2 to pi over 2. It's horizontally compressed by half, so that's why it's now from negative pi over 4 to pi over 4. So even with this 2 right here, it doesn't change anything. So your range of f is just really from negative 3 to 3. So now we can go and write domain of f inverse, range of f inverse, and all we got to do is switch what we have. Domain is negative 3 to 3, and range of inverse is negative pi over 4 to pi over 4. Either box it up or highlight it up, and voila. We're now on example numeral 5. Find the exact solution of each. Well, again, anytime you see the exact, meaning no calculator. As you can see, these all starts out with an inverse function here. That means it has restrictions right away. So make sure you're very mindful of that, okay? And you solve it regularly, except that you need to be mindful of the restriction. To get rid of the 2, you multiply 1/2 to both sides. So now you are with cosine inverse of x equals pi over 4. To solve for x, we will compose both sides with regular cos. And then cancel, cancel. X comes out to cosine of pi over 4. Well, what on earth is cosine of pi over 4? Didn't I tell you how important the unit circle is? Super important. So cosine of pi over 4, it's just rad 2 over 2. Now we got to check though, okay? Is this right here in quad 1 and 2? Sure it is. That's in quad 1, so we're good. We could get an answer. Letter B, divide both sides by -4 or multiply both sides by a -1/4. It's really up to you. So now we have tangent inverse of x equals -pi/4. Compose both sides by a regular tangent. Okay. Then now we have x equals tangent of -pi/4. Okay, so let's check this really quick. This -pi/4, is that within the restriction of tangent inverse? Yes, it is, because tangent inverse is in quad 1 and 4, and -pi/4 is in quad 4, so we're good. We can go on and find the answer. Now, because you know your unit circle really, really well, tangent of a -pi/4, it's actually -1. So final answer is x equals to -1. Letter C looks extremely scary, but it really isn't. Okay? All you got to do is combine like terms. Yes, you can totally combine inverse functions. No big deal there. At the same time, I'm going to add 2 pi's here to the right. Okay, bam. Okay, so 5 sine inverse of x, take away 2 sine inverse of x, I will end up with 3 sine inverse of x. And -3 pi plus 2 pi, I'm going to end up with a -pi. So far, so good. Divide both sides by 3. Sine inverse of x equals -pi/3. Compose both sides with a sine. And check to see if -pi/3 is in the restriction for sine. And it is, because it's in quad 4. And sine inverse can totally be in quad 1 and 4. So x equals sine of a -pi/3. Well, sine of a -pi/3, I need you to go ahead, bust out your unit circle or your memory and fill in that box. And guess what? This is the end of 7.1.